All right, so today we dove into a new unit, Unit 4, and in this unit we're going to be working with exponential functions. And so we're just going to start off by talking about the properties of exponents and going over some rules. The first thing that we need to talk about is some vocabulary so that we understand what we're doing when we get into adding and subtracting and multiplying and dividing these exponential expressions. So the first term that we need to cover is the term monomial. So if you know, if you're very good with prefixes, you know that the prefix mono, actually change that here, mono means one. So a monomial is technically called, it's a number, a variable, or the product of a number and variables. So that's like the math definition or the math name, but a monomial is just one clump, essentially, of numbers, variables. They could be raised to exponents, all connected by multiplication. That's what that word product means. So an example of a monomial would be like 5x cubed. So, and then there are different parts here and different vocab that we can go over. So this number that comes in front, right here, in this case it's 5, this is called a coefficient. C-O-E-F-F-I-C-I-E-N-T. So it's the number that comes in front of the monomial, and that's telling you how many of these things you have. And then the next vocab word is base. The base is referring to if you have something raised to a power, then the thing that's being raised to a power is called the base. And then, of course, this up here is the exponent. Now, in a monomial, you could have multiple bases, multiple exponents. So another example of a monomial would be 2a squared b to the fourth. This is also a monomial because everything is being multiplied together. And then once again, we have our coefficient right here. We have the base of a squared and then b to the fourth. And then these are the exponents on those bases. What would not be a monomial would be, say, if we added these two things together. If I have 5x to the third plus 2a squared b to the fourth. This is now a binomial because there's two terms. There's the 5x cubed term and then the 2a squared b to the fourth term. So this is a binomial. And then you could add, a third one on here. You could have xy cubed. This would be a trinomial. And then if you add any more onto that, it's a polynomial. So we're going to be working mostly with just monomials. So here are two different examples, and we're not actually going to be multiplying those together. Just want to erase that. Those are just two different examples. So now we're going to get into operations with these monomials. So to add or subtract monomials, we're going to combine like terms. This is something that we're already familiar with. When we talk about like terms, it means that they have the same base and the same exponent. So an example, or I guess a non-example, x plus y. I cannot combine these because x and y are two different bases. So these cannot be combined. They're not like terms. If I had x squared plus x cubed, these are also not like terms. They have the same base of x, but this one is squared, this one is cubed. They don't have the same exponent, so these are not like terms. But if I had something like w squared plus 3w squared, well, now we have the same base and exponent, w squared and w squared. So this is like a 1w squared, so I add them together and I have 4w squared. So this is an example of like terms right here, and that's how you would simplify. So now we're going to jump in and do some examples. Number 1 says 17x minus 25x. So in order to simplify this, we first have to ask, are these like terms? So we have a 17x and a 25x. They're both just a x to the first power, so yes, these are like terms. So we can go ahead and subtract 17 minus 25. So the difference here would be, this would be a negative 8x. All right, this next one, I have negative 23y squared plus 6y squared. In both cases, I have y squared, so I do have the same base, same exponent. So all I'm going to do is do negative 23 plus 6, which gives me a negative 17y squared. And then here, I have a negative 15a cubed bc, and then a 3a cubed bc. This a cubed bc is exactly the same, so I can combine these terms. They are alike. So negative 15 plus 3 is negative 12a cubed bc. All right, so that is our first property of exponents. So now we're going to move on to some different operations. So to multiply monomials, what we're going to do is we're going to multiply the coefficients together and simplify using the product rule. The product rule is this. If I have x to a power times x to another power, this will simplify to x. I add those powers together. And the reason this works is that if we remember what raising something to a power means, if I have x squared times x cubed, x squared is x times x. And then I'm multiplying that by x times x times x. So there's my x squared, my x cubed. Well, what this equals is 1, 2, 3, 4, 5, x to the 5th, which is the same thing as if I just added these exponents together, 2 plus 3. So that's where the rule comes from. And I say it in words as well. To multiply powers with the same base, you add the exponents. So they do have to have the same base. So in these examples, we're going to simplify by using the product rule. So on this first one, we have n squared and n to the 7th. They have the same base, so I just add 2 plus 7 gives me n to the 9th. Here I have x times x squared times x to the 4th. They all have a base of x, so I can just add the exponents together. This first x, though, we have to remember has an x to the 1. So I have 4 plus 2 plus 1, which gives me x to the 7th. Here we have some coefficients. Both of these are negative, which means I have a negative 1 out in front. So the first thing I have to do is multiply these together. So negative 1 times negative 1 is a positive 1. And then x to the 3rd and x to the 4th, they have the same base. So I add 4 plus 3, which is 7. 1x to the 7th, which is the same as just x to the 7th. And then finally over here, I'm going to first multiply my coefficients. I have negative 4 times 3, which is negative 12. Then I have a to the 3rd and a squared, so that becomes a to the 5th. And then I have b to the 1st and b to the 5th. 5 plus 1 is b to the 6th. So that's how we use the product rule. Finally, we're going to divide monomials. So this works pretty much the opposite as multiplying monomials. To divide monomials, what we're going to do is divide the coefficients and simplify using the quotient rule. Here's the quotient rule. It means if we have x to the a, x to some power, and we're dividing it by x to the b, this will simplify to x to the a minus b. If to divide powers with the same base, we subtract the exponents. So the reason this one works out is if I have x to the 4th divided by x squared, what I really have is x times x times x times x 4 times over x times x. Well, these cancel each other out, these cancel each other out, and I'm just left with 2 x's, which is x squared. So that is where which is the same as 4 minus 2 is 2. So that's where this rule comes from. So we'll look at these examples. On number 1, you don't always have to have a variable as your base. In this case, 5 is our base. So you might be tempted to just divide 5 divided by 5, but this isn't a 5. This is 5 to the 5th power, and this is 5 squared. So these are not coefficients, these are bases. So we're going to just subtract the exponents. 5 minus 2 So I have 5 to the 5 minus 2, which equals 5 to the third. Now, you don't actually have to write this step here. I was just showing you how I got my final answer. So moving on to this one, and I actually want to add in some numbers here to give you some practice with this. If I had a 2 and a 6, let's add those on here, add some coefficients. So I have 2m to the 6th and 6m to the 4th. So the first thing I'm going to do is simplify this fraction, or divide if I can. So I have 2 divided by 6, and that's just going to simplify to 1 divided by 3, because I can divide the top and bottom by 2. Then I have m and m, so I'm going to subtract these exponents, and I'll get m to the 2nd. All right, moving on here, I have p to the 5th and p squared, so 5 minus 2 gives me p to the 3rd. And then I have n to the 4th and n to the 1st. 4 minus 1 gives me n to the 3rd. And finally, this last one, I have x to the 5th and x to the 5th. Well, 5 minus 5 is 0, so I have x to the 0. And then I have y to the 3rd and y squared. 3 minus 2 is 1. So something that you need to know is that, and you can write this down, anything raised to the 0 power equals 1. So this x to the 0 really just equals 1. And so what I usually do is if I see x to the 5th, x to the 5th, the same thing being divided, I usually just cancel them out because it equals 1. But if we were to simplify it this way, x to the 0 is 1, and then y to the 1st is just y, which is really just y. So that's 3 different ways of writing this. Obviously, the simplest form would be just plain y.